Okay, so remember this game architecture. We've got the game has a lockable list of sprites. Lockable list extends array list. I'm just going to show that real quick, and I'm going to maybe go through Sprite also in this video. So let's look at the lockable list class. It's really short. There's not a whole lot here. So public class lockable list. The one new thing is lockable list of type E extends array list of type E. So this angle brackets with an E inside of it. So this is what we call a generic. Remember how whenever we create an array list, we have to use angle brackets, and inside of the angle brackets, we tell it what kind of array list, yeah? So whoever wrote the array list class typed in some line that said something like public class array list of type E. And then they wrote some methods, and inside those methods they may have referred to E. When you create an array list of a certain type, that's what tells their code what E is, and it gives the class a type. Because we're extending array list, and array list is a generic class, we're going to make lockable list a generic class in exactly the same way. And we don't really have to do anything else to extend array list. Inside of this lockable list class, because we extend array list, and array list is has a serial version, we're going to go ahead and create a serial version. This is just to stop Eclipse from complaining at us. If we don't have this, we get a warning. So that's not really terribly important. This line of code where we say semaphore lock, this is really important. A semaphore, I think I've talked about in another video, but essentially a semaphore in computer programming is used as a way to keep threads of execution from accessing the same data at the same time. Remember, they're both executing instructions. If they both try to modify a list at the same time, it causes problems. And so we need a way to lock the list. And semaphores do that. A semaphore is an object that you can create, and it has two very important methods, acquire and release. And so we're adding two new methods to array list. So we're extending array list, and we're going to add the acquire and release methods to array list. And when we call acquire, all we're going to do is acquire the lock on the semaphore that is in our lockable list. Okay, so the constructor just creates a new semaphore. This number 1 tells us how many threads can acquire the lock at the same time, and we're going to say only 1. There are occasions when you might want to allow multiple threads to all acquire the lock at the same time. For us, we're just going to acquire 1 lock at a time. So we create our lockable list. It's going to be just like an array list, except that it has a lock. A lock is going to be a semaphore that we can acquire and release. We're going to create our own acquire method, and all our acquire method does is it calls the acquire method of the lock. Now, the acquire method of a lock might throw an interrupted exception. Okay, so it's going to acquire the lock, and if for some reason it gets interrupted while it's got the lock, if it's forced to release it, it'll catch that exception, print a stack trace, and we could even say system.exit. Okay, so our program would then crash if for some reason it's forced to release the lock. That won't generally happen for us. And then our release method just calls release on a lock, and release doesn't can't throw any exceptions. It's really easy to release a lock. It's much harder to acquire a lock. What happens when you call acquire on a lock is that a thread of execution, when it calls acquire on a semaphore, if there's another thread that already has the lock, then the thread that's trying to acquire it but doesn't yet have it will fall asleep, and it will wake up when the other guy who has the lock releases it. Okay, and whenever a thread falls asleep, there's a chance that it might get interrupted. So that's what this interrupt exception is about. So if you've got multiple threads trying to acquire a lock, one of them gets the lock, the other one will fall asleep and wait until the first one releases the lock. And that forces them, even though these separate threads can execute instructions at the same time, it forces them to separate and not execute the code that modifies the list at the same time. So we allow we've got a lockable list. Before we diddle with it, we acquire a lock. After we're done, we release the lock. And that's all there is to lockable list. Sprite. I created Sprite as an interface. Anything that I figured was going to be a game object, I'm going to call it Sprite. Any game object, we need to be able to update it. We need to be able to draw it. We need to be able to figure out if it's dead, because if it is, we want to remove it from the screen. And we need to be able to figure out if it hit the puck. And so this is a contract. If something is going to be a game object or a sprite, it has to fulfill the contract. It has to have an update, a draw, an is dead, and a do hit method. And that's what allows us inside of the game class, inside of the run method, to go ahead and call update, do hit, and is dead, because everything that is in the all sprites array has to be a sprite, because it's a lockable list of sprites. And since every sprite has those methods, we can call them. In the paint class, we can call draw on the sprite, because we know every sprite has a draw method. So the interface requires that they have the methods, and then we can just stick in the game class. We don't have to think exactly about what those objects are going to do. We just know that they've got a method and that they will do the appropriate thing when we tell them to draw themselves, because they implement the interface. So that's the lockable list class, which extends an existing Java class, and it's the sprite interface that we've created.